Hello everyone, how are you today? Great? Yes? Not too sleepy? There will be a lot of pictures in this one, so I hope it will keep you attention. Okay, so where can I change the slide? Sorry, where is it? How can I move to the next slide? Oh, it's So, most teams using AI agent today are putting a motor on a bicycle. It works. You go faster, but during this talk, I want to suggest that you can just get off the bike. Because if you stay on the bike, you will go a bit faster indeed, but you will still be working under the same constraints. You will still follow the same path. And at the end of the day, you will just do the same thing, but a bit faster. Sometimes there are some radical changes. And if you, for instance, you are a mailman and you are given a bike, and every day you have to, to deliver the mail, what you will optimize is actually the distance because your muscle are at work. So you want to be very careful. You want to really optimize the path to optimize the distance. And if at some point you get a wrong turn, actually it will just waste an entire morning, for instance. While if you give a mailman a car, it's a different game, completely different game. Why? Because now you don't care about the kilometers, you don't care about the distance, you will actually optimize maybe time to delivery. You will do multiple deliveries during the day. And if at some point you take a wrong turn, well, you just do a U-turn and you just waste 2 minutes. So the first principle I want to talk about is this idea that when there is a radical change in the cost structure of your operation, you should not optimize the old process. You need to redesign one from scratch. So, here we are. Here is a model. Software development today is an assembly line. Input, ideas. Output, software. And in between, agents. They are fast, they are tireless, and also very cheap. That's given. Agents are super fast. That's their main property, what really matters. So, if you look at this picture here, you will see that agents and humans can work together on the line, and you can also have humans that are on top of them, steering the direction, checking if the work is done properly, checking if we are doing the actual right software. And this image will stay with us during this talk, because once you accept this axiom, the fact that agents are super fast, the interesting question is, what determines the quality of the output? And the answer is not the agent, it's actually the input. So that will be the main message of this talk, and I will come back on it. But before that, imagine what you can do with such an assembly line. So for instance, on Thursday, I was preparing this talk, and I was asking myself, okay, which ideas I should present today that I've been able to put at work with agents. And in only 5 hours, I was able to build a verifier for Michelson scripts. I will come back on that, and I will explain why it took only 5 hours. But before that, let me, there is this saying in French, so we are in Cannes, so I will allow myself, ne pas confondre vitesse et précipitation. In English, don't confuse speed and haste. So speed is indeed the main property of agents, the fundamental property. And you don't want to fight against this speed, because then you would fight against the tool itself. But speed without structure is worse than useless. It's dangerous, especially when you build critical software system as, you know, a blockchain protocol. So, the principle that you need to keep on top of your mind when you are using agent is garbage in, garbage out. And with agent, garbage out at full speed in unpredictable ways. Okay. So should we use agent? Yes, but we need to ask ourselves more specific questions. How do we gain trust? How can we make the output of agent reliable? And the answer is an harness. So an harness is a system that you build around agents in order to make their output reliable. How does that work? Well, there are three principles. The first one is specification and knowledge. I never use an agent, I never let an agent write a single line of code before making sure that there is no ambiguity about what I want to build. So it's very usual that I answer 50 or even more questions before starting anything. Because the moment you let some freedom to agents, the moment you let some uncertainties, you will get an arbitrary answer. You will get something that is probably wrong. So you want to give them 0 degree of freedom. Also, what is very important is to make sure that you give them the knowledge to build context that creates a very strong input. In order to do that, you need to give them the knowledge of your project and make sure that this knowledge is of great quality. So what you need to do is to do some knowledge engineering, make sure that inside your Git repository, for instance, you have markdown files indexed and optimized for agent navigation that will allow your agent to go through what you already know about the system that you are trying to build. That's the first principle. The second one is architecture and code quality. An agent is very good at doing something very specific. If you have not a good decomposition of the problem you are trying to solve, what you will get is actually some mixed and half-baked solutions. While if you have a beautiful architecture, it will focus on one concern at a time and actually fix it do it very well. What I really like in code quality, what I'm trying these days, is to use something called literate programming. I don't know if you're familiar with this concept. It's this idea that you write the code with actually a lot of comment, because you explain inside the source code why it works, why you are doing things like this or not in the other way, inside the code itself, so that local to this code, you got the answer why it has been built this way. And I can tell you, when the agent is building its context, this locality is very effective. So architecture, code quality are very good to build this famous context, so that then you will get good input and then good output. And the final ingredient, the final principle, is the feedback loop. I hear a lot of engineers telling me, oh, look, I have given this prompt to the agent, and look, that's so bad, the code it has produced. It's perfectly normal. These are stochastic processes. With some error rates, they are hallucinating. But, again, their fundamental property is velocity. If an engineer comes to you with a bad code, it's really hard to say, do it again. With an agent, there's no problem with that. And you can iterate 5 times and get a good answer at some point. Because even if you have, let's say, 10% of errors and you iterate 5 times, you have 99.9% of chance to get something good. But how do you know it's good? You need to know that in a deterministic way. You need to use test, validation, proofs, static analysis, all these tools that gives us confidence and deterministic confidence about the code that you are producing. And when you have that, you just need to let the agent work and take a nap. So, okay. Maybe you could say, okay, yes, that's a bit abstract. And I want to come back to something very practical, as I've told you before. Last Thursday, I was just wondering, okay, I have to give this talk at TezDev. What should I advertise? Let's build a verifier for Michelson scripts. What is that? So it's a program. You give it your script, your informal specification, and then it will prove that this script is correct with respect to a formal specification that you would have built with the tool. So it means that you get the guarantee, mathematical guarantee, with a proof verified on machine that your script is valid with respect to the specification. That's huge. And it took me only 5 hours to get there. Why? Because the input was excellent. The input was excellent because Michelson is a smart contract language that has been designed from the beginning to be a good language for formal verification. Why? Because it has a very control flow that is very simple. So if you build a verifier tool, actually it's super easy to generate proof obligations. It has high-level values. So it means that you don't fight against the encoding, some pointers or some encoding in bytes to reason about it. You just get some lists, maps, and a lot of high-level values like this. So it's super easy to reason about that kind of high-level objects. So that's the point. If you use an agent, if you provide it with very good input, you will get very good output. And so that's the target system I want to build today. Okay, with turning this toy verifier into actually a real tool that maybe could be very useful to the Tezos ecosystem. It's a tool that will allow you to start from your Michelson script, your informal specifications, then you interact with the agent in order to refine the specification to something that makes sense, that has no more ambiguities. And when it's done, well, you just get it run. Why? Because the agent will produce proof, and you have deterministic ways to verify that these proofs are correct. So there is no other way to trust an agent. It comes with a proof that it's correct. And in this pipeline, I won't detail it, but at the end, what you got is actually what is called a proof in the ROC proof assistant. It's a certificate that you can just read, and you know that the script actually is bug-free. Okay? What I want to emphasize on this diagram is not really the diagram itself. It's simply that in the front end of the diagram. You have some agents, some non-determinism, some interactions with agents that can be a bit, stochastic. But at the end, you have only deterministic tools that will provide validation. Okay? So that's one data point. But there are others. For instance, the Inadar guy from Nomadic Labs asked ourselves, okay, can AI agent reduce the cost of using mechanized formal methods in the development of the TezDev protocol? So something that is real, that is used in production. And the answer is yes. She did 4 experiments. I will present 2 today. One is proving that the token module in the layer 1 protocol behaves correctly. This token module is super important because that's where everything regarding Tez is done. You really want that to be done correctly, right? And what she was able to do is to take the property-based testing that we already had in the code base, all the design docs that we had, all the properties that we have written, and use all that to generate a verified model. What's a verified model? Again, it's something you can trust because it's mathematics. Mathematics on the machine. In a very verified way, you know that this object is valid. She also took what has been presented by Matthias earlier, the liquid staking white paper, and she took also the design docs that we had, all the properties that we had, and she was able to build a mathematical model, again, on the machine, verified, and mostly perfect. The same architecture applies. We provide some input to the agent. This input is, a lot of documents in natural language. You work with the agent to refine, to formalize it on the machine, and then you have this possibility to just let the agent work because you have a deterministic tool that will verify that the agent is not doing anything wrong. So, I want to draw some conclusion now. And this conclusion is about the relationship between the TezDev ecosystem and formal methods. We have been investing a lot in formal methods in the day, and it's paying out. We can see that with Mikkelsen, for instance, that is a very well-designed language. That's not an accident that it's good for formal verification. It has been thought that way. It's the first principle. So you take that basis, and you are able today to leverage it in order to get code produced by agent that you can trust. So the culture itself that we are following, the TezDev engineering work, is actually the harness. It's the design of Mikkelsen that is the harness. It's this methodology based on first principle, on math, on properties, on formal semantics, that is now a big advantage for us. So, in the past, formal method was a luxury. Now, it becomes probably a competitive advantage. And the TezDev ecosystem has invested a lot inside this formal methods approach. So today, we have a factory, we have very good input, and the only question is if we want to be assembling by hand or just run the line. So I've been talking about how to build software right. And the next talk by Arthur Bretman will be about how to build the right software. So it's the second part of the equation. You probably want to hear it. But mine is done. Thank you.
Thank you, Yann, and thank you for helping me warm up the audience for the next talk. Now we're going to have a very quick round of Q&As. I probably start with a question for you. Now, what is the advice that you would give to developers today? What should they be doing right now?
Right now, I think the low-hanging fruit that has the most impact is to import all your knowledge inside your Git repository, simply as markdown files, well indexed, so that agent can navigate efficiently. And you will see immediately the effect on this on the output of your code agent. That's what I've noticed in many occasions. It's extremely powerful. So you don't need all this linear GitLab, etc. You just need a Git repo with text files and let your agent work with an harness.
No, okay. Well, thank you, Yann. Thank you very much.